Hello, in this video I'm going to show you how you can test for heteroscedasticity in your regression model. Now, heteroscedasticity is a situation where the variance of the errors in your regression model are not constant. Now, we know that under the OLS assumptions, the variance of the errors have to be constant. So heteroscedasticity violates the OLS assumptions. That is why it is important that we test for heteroscedasticity after we run our model. In this video, I'm going to show you how you can test for heteroscedasticity using Stata 13 after you run your model. The first thing is that you have to have your data loaded in your Stata. As you can see, my data is loaded in Stata. In a future video, I'll show you how you can load data in Stata. So let us run our regression. So to run your regression, you're going to run this command, reg, and then you are going to click on these variables. So for the sake of this tutorial, I'm going to take CPI as my dependent variable and open and GTPPC as my independent variables. So yeah, then after this I press enter. So this is my regression. How do I know that there is heteroscedasticity, or maybe there is no heteroscedasticity in this model? Heteroscedasticity is tested using the Breusch-pagan test, and this is what we are going to do in Stata. So to run the Breusch-pagan test, you are going to run this command, head test, HETT EST. Yeah. So head test, enter. So what you have now is the output from the Breusch-pagan test. Now what we have here is we have the null hypothesis, constant variance. So the null hypothesis states that the variance is constant. The Breusch-pagan test will help us to prove this hypothesis. So how do we know? How can we test for heteroscedasticity? We are going to look at the p-value, this p-value. Now the rejection rule is reject the null hypothesis if the p-value is below the level of significance 0.05. I repeat, reject the null hypothesis if the p-value is below the level of significance 0.05. So what is our p-value? Our p-value is 0, which is below the level of significance. So what we're going to do, we are going to reject this null hypothesis that there is constant variance and conclude that the variance is not constant, meaning that heteroscedasticity is present in our model. That's all. Thank you very much for watching.